Cloud environments can be a mess. Resources get spun up, some disappear, some just linger. But what if I told you that Terraform could help you find all of these resources? So that is what we're going to do. Today we're going to dive into a powerful Terraform feature that is going to be a game changer for us cloud engineers. And this is a problem because many of us we inherit cloud environments, and these environments just kept on growing. It could be because of a large lift and shift migration. There's been a lot of manual changes that we are unaware of, and obviously these are resources that are created outside of infrastructure as code. And what do we have? What have we inherited? Well, we've inherited an environment with a lot of configuration drift, security risks, and generally just a bad time. But what if I told you that Terraform, the tool that you are already using, has a new functionality that helps you identify and find these ghost resources? So as a cloud engineer who's had to deal with unmanaged infrastructure, and I'm gonna assume that you have been in this position as well, that's why you're here, I'll show you exactly how this feature works and show you how to work with it in your daily workflow when you're running your Terraform operations and how it can make sense. Just quickly before we start coding, I want us to be on the same page about unmanaged resources and why they are problematic. So when we think about configuration drift, something was created with code, for example Terraform, and since that deployment someone has changed that resource or deleted that resource, so it no longer fits the code. I would actually argue that even resources created outside of Terraform are also configuration drift. Because when I think about configuration drift, I think about what is my intended state and what is my actual state. And bear in mind, this is not Terraform state I'm talking about. I'm talking about the state of my cloud environment. We can tell who made the change and we can tell what the change was, but we can never figure out why. And that is the big thing about infrastructure as code, the why behind changes. And this is like any resource that you have that isn't under the control of infrastructure as code. It is just prone to configuration drift, and I would even go as far as saying it's just inevitable. And I don't think this is a minor issue. I think that this is something that if you don't take care of it, it's just going to grow and grow, and you're going to have more configuration drift, and you're going to have more security concerns and more rampant costs just running amok. So I think this is very important. And that is why I'm so excited about this search function that we're going to delve into next. So I have gone ahead and bootstrapped a new project here. It's called Terraform Search. So I just gone ahead and added the Terraform block and the provider block, as well as some variables that I want to use, and also a variable file. I should mention that in order to be able to follow along and actually use this Terraform search function and to be able to work with the list blocks that we're going to look at in a bit, you have to have Terraform version 1.14 or later. To find out which one you have, you can write Terraform --version. I have v1.14.4. And actually, before we start writing, we could actually check on the documentation. So I'm going to leave a link to this in the description. But here we can see that here we have the list block reference. So we can see that we can make list blocks, and it's going to read configuration, and we want to place those inside a tfquery.hcl file. Something else that is also very important to understand is that different providers will work with the list function or the list block in different ways. A lot of the examples from the Terraform documentation is for AWS, so you have to make sure that you check with the provider that you are working with and what they support. So if we go to AC API that we have here, for example, for managing Azure infrastructure, we can see we have list resources, and it supports the AC API resource. However, this one is important. The AC API resource list resource is in beta. So we just need to keep in mind that when we're working with this, that it is still in beta and that weird things may happen. If I go to browse providers and go to Azure RM instead and view the documentation, I can see that it doesn't appear like we have a lot of support for list. So all of these have resources and data sources, but no list. It doesn't seem like Azure RM works well with this yet. But let's get going. So if I create a new file in here and I call it log.tfquery.hcl, in here I want to go ahead and declare a list block then. Nice. Now, how do I configure this? The example, I can see that they have configured which provider am I working with, also a config block where they say a type and a parent ID. And I can see the only required thing I have to set is actually the parent ID. And this is important. It supports different kinds of deployment for top level resources. So as far as I understand, if I set this to my subscription, for example, this should search for these types of resources in my subscription. So I want to search for log analytics workspaces, and that's why I call this file log. But the type is still an AC API resource, and the name we should say log analytics workspaces. Remember, we had to set the provider. I'm working with AC API, and then we add the configuration block. So in here it wanted the type, so we can grab this. Now this doesn't autocomplete the type I need. I could look it up, but I could also just jump into my main.tf where I can declare a resource block, say temp. I'm not going to use this. All I want is operational insights workspaces in the API version. So I'm just going to grab that and remove this and go back into my file and say the type there. And then I have to say the parent ID. I haven't actually checked if this works, but I could say, maybe I can work with a locals inside of this. So I think I'm probably going to use this a lot of times. So I could just say subscription resource ID like that and say subscriptions, and then it wants my subscription ID. So I'll just say show. Gonna grab my ID and put it here. So then I have a formatted subscription resource ID, because remember in the documentation, that is what it looked like. It wanted the parent ID. So if we come back here, can I say local subscription resource ID? Okay, it did not like that. Can we place this inside of here? Okay, so it doesn't work cross file, I guess, and that's fine. But we can keep it at both places. So I'm gonna keep this as such. So if we bring up the terminal and we say Terraform init to initialize this workplace, or to initialize this project. Now, if you were to run Terraform plan, and we have to specify a file for this, I'm using a dev.tfvars for a variable file. If I just run plan, I just get this. Your infrastructure matches the configuration. And this is actually by design, because plan and apply tries to apply a configuration in your regular Terraform files, but is not aware of this just yet. And that is where we can use another command that's called Terraform query. So if we check the help for this one, we can see it queries the remote infrastructure for resources, and the remote infrastructure in our case is going to refer to our provider, so that's AC API, and it'll search our tfquery.hcl files. So I'm just going to run Terraform query var file variables dev. A local value name subscription resource ID was already defined. Okay, we'll go back in here and we'll just do that for now. So it found a few workspaces actually, and this is a little bit difficult to read. We could do, I'm gonna output this to a JSON file instead. This is not the JSON format, but it just makes it a little bit easier to work with. So we can just take these, do that, and here we have it, or not quite. We want to make sure we grab these as well, do it like that, just grab these. So here we have it. We have the symbolic name or the list name, whatever you want to call it. We have the ID, so this would be the resource ID, then just the type, we know what the type is, and then the actual name of the Log Analytics workspace. But we're just going to pretend that we don't care about these others for now. I am interested, however, in this one called LogDev SE Pro module. So how can I narrow this down? Well, if you remember, we can use parent ID to narrow or widen our search. So I could grab the parent ID of this one all the way down to the resource group. We'll come back in here. We're going to actually replace this with the resource group parent ID. Then back in here, if we run the query again, we don't output it, then I return one operational workspace. So now that I've found this, what can I do with this? Because this query in itself, it didn't do anything. It just gave me information about, yeah, here's a workspace that you have based on the parent ID you provided. Well, if we look back in Terraform query, the help section, we can see we have something called generate config out and a path. And this is going to instruct Terraform to generate the import and the resource blocks. And this is huge actually, because when some time ago there was like a lot of noise about now you can create a resource through the wizard in the Azure portal, and then you can go to export and you can choose AC API or Azure RM for Terraform. Previously all you had was like ARM and Bicep. However, I don't know what the status is now, but back then it didn't generate the import block. It just generated like a resource block. But here we can see we get both import and resource blocks. And this is important. The configuration is written to a new file at path, which must not already exist. So I can't output this into my main.tf because it already exists. So if I just copy that, go back to our command, and I'm going to add the generate config out. And we'll say import.tf is a new file. And press enter. So we have the same output in the terminal, but we do have a new file called import.tf. And here you can see it's been generated by Terraform. Well, yeah, sure. And here you can kind of see that it is in beta. Like we have a lot of information. Most of this we don't even need, but it also gives us the import block, which is awesome, right? So let's look at this. What are we actually seeing? So yeah, I could run this if I brought up the terminal again and we ran the plan command. We could see that we have one to import, and it would be this one. However, I wouldn't import this the way that it looks right now because it looks, to be honest, not very great. And we actually want to fix this before we do anything. So I don't like the symbolic name, Log Analytics Workspace 0. And what if we would have more in the future? Would it just be 1, 2, 3? I don't understand that. So I'm gonna do Command Shift L to mark both of these because we have to update the import block as well, remember? And I would just switch out that one to Pro Module. And if I create a new Log Analytics Workspace in here, it's gonna have a better symbolic name and I can differentiate them. The second thing we have here is that Azure has imported, or Azure, but Terraform has written out all the values that exist. The problem with this is that a lot of these are read-only, so we don't care about them. So we have to do some cleaning. If we skip the body initially, we're just going to go through here and say create headers, query parameters, delete headers, delete query, like all of that I'm just going to remove. Ignore casing is kind of nice. We can actually set this to true. What this means is going to reduce some noise that you sometimes get in the plan output when you're working with the AC API. Sometimes Terraform will tell you that this resource is going to be updated in place, and you look at the old value and the new value, and they are completely the same except for that the old value may be all lowercase and the new value may be camel case or whatever, and then it's going to think that something has changed. But if you set ignore casing to true, you don't have to deal with it. These other things, like I'm not even sure what they do. So location is good. That's something we want to have, but we are not gonna hard code that. We're gonna say var location. Logs I don't care about. So the name here I want to use string interpolation. So I don't want to say dev. I want to say var environment. I don't want to say SC. I want to say var location short, and pro module can just be pro module. Parent ID, and that's almost correct, but we could actually remove that part and do local subscription resource ID. It's gonna complain at us that we don't have that local. We do actually have it, but now we need to call this. You know what? I'm gonna do subscription resource ID. Then to make sure we don't have a problem here, I'm gonna say query subscription resource ID and update. I don't need to update that. Then we can come back here and we can use the local for that. I could use a variable, I guess, but I've done all this work now. Then we have a bunch of other things. So read headers, all of this, we don't care. Response export values, if we export anything, we want to use it with other resources, that's pretty good. I don't have anything to export right now, but I can put an empty square bracket like this to just denote that I'm just not outputting anything. We don't need to use a retry. Schema validation is fine. We're not using any sensitive bodies, so we can remove that. The type is interesting, we're gonna keep that, or it's interesting, it is required, so we're gonna keep that. And then we're just gonna remove the last two that we have there. So let's tackle a few things. Now, parent ID, name, location, I always keep at the top, and I always put parent ID, then name, then location. Sorry, that's not what I do at all. I actually grab type. I have type, name, parent ID, location. Provider, I don't need to have here. I'm just gonna get rid of that. And all these other ones I usually keep at the bottom, so that's fine. So now we have to deal with the body block. So we have something called etag again. It, just like how the portal export works, is gonna export read-only values, which we don't care about, so we're just gonna remove that. Then we have a few other things. Not sure exactly if we need to touch any of these. We can just keep them. If we were defining this resource from scratch, I maybe wouldn't define things like this if I didn't have to, but for now I'm just going to keep it. The import block I will keep as is. You may be a little bit confused that you're using identity here, or it is using identity. When I write import block, I usually only specify two, and then I would say the resource and then ID, which would be the resource ID, which is actually this property here. But you can actually do it this way too, I think, where you can say identity and you specify the type and the resource ID. It doesn't really matter. I guess this one is a little bit more safe or validated, but it doesn't matter. So now I think that this one looks pretty good, and we can go ahead and see what happens if we try and run this. So in my terminal, I'm gonna run plan. Oh, it wants me to run init again. Okay, so here's actually a problem then. In import.tf on line 36 is saying you don't really need to specify this, but this was something that Terraform search gave me automatically. So remember how I was talking about it is in beta? Well, there you go. So let's run init again, and we can run plan. So we have still one resource to import, and that is the log analytics workspace. We can see it's kind of says removing the etag. I don't think it actually matters. Ignore casing. I guess default is false. We're gonna set that to true, and it's just gonna do something with output and gonna add a response export file. So no changes that actually have any consequence on the resource itself. So I like this. So we should say, instead of plan, we should say apply, and I will toss on an auto approve here. And there you have it. So one resource imported, we can see it import set complete, and then it modified those things that it said it wanted to modify, but it doesn't actually matter. So now the last important steps that are crucial for when you're doing this, no matter how you're importing resources, we want to make sure that we clean up our import blocks. We don't need those. And actually, I'm just going to take this entire resource, clear this out, go into main.tf, I'm just going to put it here. So now this log analytics workspace is under our management, and then we can manage it. So if we go into the portal and we go into usage and cost, you have things such as data retention. Here you can see the retention is 120. Let's say we wanted to reduce that to 90 for whatever reason. Let's bring up the terminal, run a plan. So we can see it wants to change from 120 to 90. I like that. So I'm just going to say apply and auto approve. And this was a huge success. So apply complete. Then in the portal, if we do a refresh and I'm going to open data retention, we can see now it says 90 days. We could go to overview, click on JSON view, and we can see here it says retention in days, 90 as well. So the example we just did, we searched kind of wide and then we narrowed based on what we found, but perhaps we would want to filter in different ways. And if you've read about this functionality, this new search functionality that is, you probably have seen that in the examples they have things such as filter. And this is within the configuration block. So here you could say that the filter should be that the name, the instance state name, and the value should be running. You could search for things by tags, for example. Here they have an example where you could search for managed by tag or unmanaged. So a problem if we are working with Azure, which we are, is that if I come to my configuration block and I see what I can do, I don't have a filter. I have headers and I have query parameters. So query parameters is actually a map that is a list of strings. Oh, it says even here, map of a list of strings. This is how we can filter, but we are a little bit limited. Whenever we are working with creating or updating resources in Azure using Terraform and now the AC API provider, but even if we're using Azure RM, essentially what we're doing is we're making calls towards the ARM API. And when we are using list, as we're doing right now, at least from my testing and research and as far as I can tell, we're hitting a specific endpoint for the ARM API. So just as an example, let's say we make a new list block of an AC API resource. I'm going to say, I want to see all the resource groups that are not managed here. Or not managed, but I just want to search for the resource groups. All right. So I have to say the provider, again, that's AC API, and then do my config block. No problem here. The type is actually this, and I can do parent ID, and I'm going to do local query subscription resource ID. So now I'm going to search for everything in here. So let's remove that for now. Bring the terminal, and I'm going to run Terraform query var file variables dev. Now I receive a bunch of resource groups, which is great, right? However, imagine if I had hundreds of these, or I don't know, thousands of these. Like, how can I filter this? One thing that would have been nice if it was possible is, what if I could do query parameters, say, here I actually have to say something very specific. I have to say filter as such, and then I have to specify my list of strings. And then I did like name equals, and then in single quotes, rgdev. This would have been pretty nice, but if I run this, I'm going to receive an error message. It's going to say invalid filter in query string. And if we actually look at this error message, we see that it failed to list resources and the URL resource group. So it's an HTTP GET towards managementazure.com subscriptions resource groups. This is actually the collection that is just listing resource groups. It's just a list of strings of resource groups. It's not the same as if I did an HTTP GET towards a specific resource group resource where I could actually filter by name. If you're confused, don't worry, I'm gonna explain to you what I'm talking about. So here we have the REST API documentation for resource group and list. And if you remember, here it says managementazure.com subscriptions, then the subscription ID, and then it says resource groups. And if we look in our error message, we have the same. So what I can do is I can play around with this. They have a client for me where I can perform API calls. So if I click try it, I'm gonna get to log in. So I've logged in with my account, and here I can, through this UI that they have, I can switch to my dev subscription. You can see up here it's gonna switch the subscription ID, and then I can give it a few parameters. It's already prepared some parameters for me. However, if we come to the left here and check in the documentation, it says the parameters you can give it is subscription ID, again already given for us, API version. If I wanted to change that, I could. Then you have this $filter, and remember we did a query and we changed the parameters, but we have to say $filter. And here's the kicker. Since this is the same collection we are working with in Terraform, as we see here, you can see that you can filter by tag names and values. So I can filter for a tag name and value by using this filter. I cannot filter by resource group name. So if we just try this, I can copy this and say filter, and then I'm gonna grab their example where they just say tag name equals something, tag value equals something. So tag name equals, actually, I'm doing this in the wrong order. I'm not gonna change anything. I'm just gonna click run. When I click run, I get all of my resource groups, every single one of them. And this is exactly the same that happens if I just take this query parameter section and comment that out, and I run my query, I get all of them. So I just switch to development, because that is the subscription I'm working with. I'm gonna grab the parameter they specify here, $filter, and then we're just gonna grab this example that they have. So tag name and tag value. I've prepared a resource group with these tags already, or one of the resource groups actually. So if I did managed by, and then we'll come to the end here and say just unmanaged. So the idea is that we've had something that tags everything as unmanaged unless it's been changed by someone, just to identify things that don't exist. And this is important. This is what I trip up about all the time. If I click run, I get all the resource groups still. And why is that? Well, it is because the user interface is super not intuitive. You have to click the plus icon here. If you do, you can see that the request URL has now been updated and changed. Then we come down and click run, and now I only receive one resource group. So this is what we're trying to achieve inside here as well. So I'm just gonna put this back like we had it and say filter, because that is what the parameter name is, remember? Then it was a list of strings, so we have to specify that. And then we just say pretty much the same thing. We just say tag name equals managed by, right? And that has to be in single quotes. And we can say and tag value unmanaged. Open up our terminal and we're gonna run query, and hopefully we only receive one result. Oh, I forgot. Tag value equals unmanaged. Whoops. Query again. And now we get just the one result, which is awesome. So now that we have this, let's just do what we did before. I'm gonna say query, and I want to generate some config, so I'm gonna put that in import.tf. Oh, remember, it has to be in a new file. So we're gonna say import rg.tf and see if we can run that. Yeah, seems like it could. We're going in here, and then we have the same thing. So then we just have to clean up the provider. I'm not going to care about the names right now. We're going to speed run this. Just going to remove that. Body, we're not going to need. All of these, I'm just going to go ahead and remove. We're going to do this super quick. The locks, we don't care about. We're going to do that. The type, we want to be a little bit civil. So the type should come first, then name, then location, then parent ID. Or was it parent? Yeah, parent ID, then location, I think. We're going to remove all of these. We don't need them. Schema validation can be true. We are not using sensitive body. So tags, really interesting now, because it says unmanaged, and that's how we found it, right? But now we are importing it and bringing it under our control. So we're actually going to say managed by Terraform, right? Then we'll come into our terminal and say plan again. And we have one resource that is going to get imported. It says that the tags are going to change from unmanaged to Terraform. Yes, please. I'm just going to run apply. That is successful. Here I am in the portal. I haven't refreshed yet. It says managed by unmanaged. If we do a refresh here, we can see managed by Terraform. And just to make it super clear, if we run the query again, we don't need to import anything. It returns 0 results. So guys, that's how you do it. If you thought that was interesting, be sure to subscribe to the channel and like this video, because I'm going to make more videos that cover infrastructure as code and Terraform and how to manage cloud resources. That's like my thing here, and I think you would really like this video. It's about troubleshooting Azure networking. If you think that's interesting, then check that video out. If not, I hope you have a great day, and I hope to see you in the next video. Thank you very much for watching, and take care. Bye bye.